Hi guys, before we start, I'm going to explain about cinnamaldehyde. Cinnamaldehyde is an organic compound that belongs to the class of aromatic aldehyde and is characterized by its spicy and sweet aroma. The compound is a yellowish liquid at room temperature but can solidify at lower temperature. The molar mass of cinnamaldehyde is 132.16 gram per mole and the IUPAC name of this compound is 3-penyl prop 2-enal. And next, cinnamaldehyde is predominantly found in cinnamon bark, particularly in species such as Cinnamomum cassia or Chinese cinnamon. It is extracted from the bark through various methods including steam distillation or solvent extraction. Due to its pleasant aroma and antimicrobial properties, cinnamaldehyde finds application in the food industry such as natural preservative and flavor enhancer. It is also used in the fragrance industry for its warm, spicy scent in perfume and personal care products.
Now, let's move on to the physical and chemical properties of cinnamaldehyde. Firstly, the appearance of cinnamaldehyde is yellowish to pale yellow color. The odor of cinnamaldehyde is described as warm, spicy, and sweet reminiscent of cinnamon. Apart from food and fragrance industry, cinnamaldehyde is also useful in pharmaceutical as an antimicrobial agent. At room temperature, what form does cinnamaldehyde take? At room temperature, which is between 20 to 25 degrees Celsius, cinnamaldehyde exists in liquid. The fourth property is the melting point. Melting point is the temperature where a substance changes from solid to liquid state. At this temperature, the solid and liquid phases of the substance coexist in equilibrium. The melting point of cinnamaldehyde is -7.5 degrees Celsius. That means, below this temperature, cinnamaldehyde exists in solid, whereas over this temperature, cinnamaldehyde will become liquid. Next property is boiling point. Boiling point is the temperature at which the vapor pressure equals the external pressure surrounding the liquid, where the liquid will turn into vapor. The boiling point of cinnamaldehyde is 248 degrees Celsius. At this temperature, cinnamaldehyde will change from liquid state to gaseous state. Last but not least is the flash point. Flash point is the lowest temperature at which its vapor can form an ignitable mixture with air. It is a critical property to assess fire hazards of liquids and is used in safety regulations and guidelines. The flash point of cinnamaldehyde is 71 degrees Celsius. Cinnamaldehyde needs to be heated to this temperature before it can produce vapor that will ignite in the presence of ignition source. That is all from me. Thank you.
Now, I'm going to explain about the benefit of cinnamaldehyde. First, anti-cancer. Cinnamaldehyde found in cinnamon were able to activate the detoxifying enzymes. A study on human colon cells in test tubes showed that cinnamaldehyde could activate the antioxidant response that kill or stop the spread of cancer. Second, prevent neurodegenerative disease like Alzheimer or Parkinson. Cinnamaldehyde was found to inhibit the buildup of the protein which causes Alzheimer. Cinnamaldehyde helped protect the neurons within the brain and normalize neurotransmitter levels while also improving their motor function. And the last one is, it can regulate insulin levels and lower blood sugar. Cinnamaldehyde can drastically reduce insulin resistance and lower blood sugar levels. Cinnamaldehyde mimics insulin, which greatly improves glucose uptake by your cells. Last but not least, it is confirmed that cinnamaldehyde has anti-diabetic effect, showing that it can lower fasting blood sugar levels by 10 to 29%. Moving on to the next slide, I'm going to explain about uses of cinnamaldehyde. First, therapeutic uses. Enhancing oral health. Cinnamaldehyde helps to fight against tooth decay and bad breath. Second, as an antibacterial and antifungal agent, effective for preventing the growth of bacteria and other pathogens in the tongue. It had been found that cinnamaldehyde prevents above 50% of the bacterial growth in the oral cavity. It effectively inhibits the growth of various of bacteria, fungi including yeast, filamentous molds, and dermatophytes. For example, cinnamon toothpaste. And the last one is as a flavoring agent. Cinnamaldehyde is mainly added to foods and medicines to enhance its quality in terms of aroma and taste. It is used as a flavoring agent in liquid refreshment, ice creams, chewing gums, and candy. It is also used in perfumes to recreate the magic of fruity and interesting fragrance ranges.
Hi, my name is Danish Iskandar bin Muhammad Zamri. My student ID is 2022801292. And in this part of the presentation, we will be exploring the chemical reactions of cinnamaldehyde. So, firstly, we need to know the structure of cinnamaldehyde. First, it has a benzene ring, which is a 6-carbon ring with alternating double bonds. And we have an aldehyde group of CHO group, which consists of a carbon atom double bonded to oxygen and single bonded to a hydrogen atom. So, in general, this is the structure of cinnamaldehyde. So, first things first, the first chemical reaction of cinnamaldehyde is oxidation. So, oxidizing agents can convert the aldehyde group, CHO, in cinnamaldehyde to a carboxylic acid group. So, an example reaction of this is cinnamaldehyde plus an oxidant equals cinnamic acid. So in this reaction, an oxidizing agent like potassium permanganate or chromium trioxide is used. The next chemical reaction of cinnamaldehyde is reduction. So as we all know, reducing agents can convert the aldehyde group in cinnamaldehyde to an alcohol group. Example reaction of this is cinnamaldehyde plus 2H equals cinnamyl alcohol. So what cinnamyl alcohol is basically it's a alcohol form of cinnamaldehyde. So common reducing agents including sodium borohydride and lithium aluminium hydride. Next up is the aldol condensation. So cinnamaldehyde can participate in aldol condensation reactions where it reacts with another molecule containing an active hydrogen like another aldehyde or ketone. So an example reaction, when cinnamaldehyde reacts with acetaldehyde, the product is a compound with a longer carbon chain. The alpha hydrogen of acetaldehyde is removed, forming an enolate ion. This enolate ion attacks the carbonyl carbon of cinnamaldehyde, forming a new carbon-to-carbon bond. So, lastly, you have the Michael addition. Cinnamaldehyde can undergo Michael addition reactions where a nucleophile adds to the beta position of an alpha-beta unsaturated carbonyl compound, like cinnamaldehyde. An example reaction of this is a nucleophile, such as a thiol or an amine, adds to the double bond between the second and third carbons in the chain. The nucleophile then attacks the beta carbon, breaking the double bond and forming a new single bond. The electrons from the double bond move to the alpha carbon, temporarily forming a negative charge which is stabilized by the carbonyl group.
In conclusion, cinnamaldehyde is a versatile organic compound primarily derived from the bark of cinnamon trees, especially Cinnamomum cassia. Its distinctive sweet and spicy aroma makes it highly valuable in the food and fragrance industries, where it is used as a natural preservative, flavor enhancer, and perfume ingredient. Beyond its aromatic properties, cinnamaldehyde offers significant health benefits. It helps prevent neurodegenerative diseases like Alzheimer's by inhibiting harmful protein buildup, exhibits anti-cancer properties by activating detoxifying enzymes, and regulates insulin levels, effectively lowering blood sugar and offering anti-diabetic effects. These diverse applications and health benefits underscore cinnamaldehyde's importance in both industrial and also therapeutic contexts. That is all from us. Thank you.